Hello and welcome to the Cloudwick Machine Learning Quick Start tutorial. This Quick Start was developed by Cloudwick, an advanced partner with big data, DevOps, and ML competency with Amazon AWS. This ML Quick Start is an automated machine learning platform that can help a business by providing an end-to-end machine learning solution from the data engineering side to the analytics, and finally, the API endpoint used by the consumers to query against the machine learning platform. To use this platform, all the customer has to do is upload the data, perform basic analytics capabilities, and then utilize Amazon SageMaker's machine learning capabilities to create API endpoint that can then get consumed by consumer on a regular basis. Now, as you see here, this is the landing page of the tool, and on the right side, you see a drop-down of various use cases that has already been developed. Apart from healthcare, we have developed similar solutions in retail, finance, telecom, and transportation. Now, the purpose of this use case is that we're trying to model the probability of occurrence of a disease. And the disease that we're talking about here is dementia. Dementia is a general term for a decline in mental ability severe enough to interfere with daily life. And in this use case, we propose to develop a sound model that can help clinicians predict early Alzheimer's for proactive identification. What we'll achieve at the end of this is that we'll have a dashboard that the doctors can basically use to track how the possibility of dementia has changed for a patient over multiple visits. Now, in the next page, we get a basic overview of the data set. We have longitudinal data of a collection of 150 subjects aged 60 to 96. And each subject was scanned on 2 more visits, separated by at least a year. And during those visits, various demographic as well as clinical related information was captured. And if we hover over to the column definitions tab, we see a description of those features. For example, the MRI visit delays days. This is nothing but the days since the first MRI scan was performed for the patient. Other information like patient's age group, patient's years of education, socioeconomic status, patient's gender, as well as other clinical related information like estimated total intracranial volume, which is nothing but the volume of the cranial cavity. Now, moving on to the next page, this page provides some guidelines that we have used for integrating this solution with various AWS services. For example, the desired S3 bucket name when uploading the data. You can actually directly skip to the inference page in which you'll be able to query the machine learning endpoints and consume this application. Or you can also check out the SageMaker notebook that we've used to develop the machine learning aspect of this platform. The idea behind this is that the machine learning team can basically use this notebook to modify the analysis and present this analysis to various stakeholders. Now, here we see that we have imported all the libraries, and then we have imported the data from the S3 bucket, and then we performed some basic data exploration and visualization. For example, we performed visualization to know the effect of age group and education on the possibility of dementia. And then we use this data to train the SageMaker's XGBoost ML algorithm. And then after training the ML algorithm, we deploy the API endpoints. Now, let's get back to the inference page. Now, to demonstrate the applicability of this tool, I'll enter some dummy data points. For example, let's say this patient visits for the first time. The MR delay would be 0. Let's say the patient has 12 years of education. The socioeconomic status is high. The intracranial volume is 2000. The normalized whole brain volume is, let's say, 75%. The patient gender is male. The age group is 60. And the average percentage decrease in whole brain volume over multiple visits is 0. Now let me add one more visit for that same patient. Let's say the patient is visiting after 600 days. Everything else remains the same. Only the normalized whole brain volume, let's say, decreases to 45%. The patient's gender remains the same, the age group remains the same, and the average percentage decrease in whole brain volume recorded over multiple visits is 40. Now what is happening here is that the graph is querying the SageMaker endpoints and then displaying this result. This is a very good example of the applicability of such a tool. The doctors can basically track how the possibility of dementia has changed for a subject and its multiple visit. For example, in this case, it is increased from 57% to 72%. Now, this is a very simplistic classification model, and you can use this platform in varieties of other complex use cases. And since the entire infrastructure is deployed as a code, we can even enhance its capabilities by adding on more services in the backend. That was all for the tutorial. Thank you so much for watching.